So in this small presentation, I'm going to go through all the steps, the basics that you need for machine learning. Right, now the very first thing I'm going to discuss with you what kind of a learning is possible. Now remember the term machine learning means learning usually can happen by teaching, or you being self-directed learning, meaning like you direct and then you learning likewise. So we will try to teach computers to learn here, right? So the idea is, instead of a human working on a particular task, we will teach a computer to learn something. So there are different ways of learning is possible in this, right? So let's start with that one. Now the very first thing that we are going to discuss is called classification, and commonly used machine learning problem where we are training a computer to classify something. Now when I say classify, it's something like a weather. Now for example, what will be the tomorrow's weather? Is it sunny? Is it rainy? Right? Is it overcast? So that is a classification problem. Or if you have given a set of patient records, and the computer program should be able to identify who's having cancers. In communication level, like dialogue for example, given a set of customer details, we should be able to identify who's about to switch from your service, right? We call churning, right? So we have churn and unchurn. If you have like loan application program, we can have a computer program to decide whether to provide a loan or not, right? So this is called classification problem. Basically you are trying to identify particular class value. That means as I said you earlier, whether it's sunny, rainy, overcast, or whether it's having a cancer or not, whether you are going to accept a loan or not. So it will be some particular value we are going to define, and that's what we call classification. And this is also known as supervised learning, because we are provided with historical data with labels, right? So all these learning happens with providing data. So that's the main thing. So all these data-driven modeling based on a lot of data. Right. Now second problem, if you look at the second problem, it's called association learning. Sometimes we are interested in looking at what customers purchase together. So if you are in a service industry, so you are interested to know what services customers selects, for example. Or in a shopping mall, for example, we are interested in finding out what customers purchase together. Now, for example, if you have experience in purchasing in website like eBay or Amazon, when you purchase something, it will also recommend those who have purchased this also purchase that, and you are getting some recommendation. In movie rental sites, they are recommending movies. So this is called association learning. Instead of learning one particular value, you are going to look at association between these attributes. Okay, so this is called association learning. Again, another type of learning. Third one is called clustering. So sometimes we can see groups. Even in a class, we can see there will be some groupings. So there should be a reason, isn't it, for these groups. Right? Now, for example, you can take customer groups. Right? Some we call loyalty customers. You can group the customers. So if you are trying to look some groupings in your data, that means if you are trying to group similar records, then we have to use clustering. This is called unsupervised because we are not providing any label or classification like in previous case. And the other common type is finding a numerical quantity. We call numerical prediction. right? For example, given different specification, we want to find out CPU performance or market share value, right? What will be the market share value for tomorrow, right? So you are going to predict a particular value, or a number, you are trying to predict the COVID patients tomorrow, right? So that means you are going to predict a particular number. So this is called numerical prediction. So these are, of course, we can take it as a basic types of learning. There are many others, but these are very commonly practically used, and you can see even in the most of the websites you are visiting. Right. Any questions on these different types? Okay. Before we continue, like, how many of you are already familiar with the machine learning, or you are actively using machine learning in this class? Can you please raise your hands? Okay, no problem. Yeah. So I'm assuming that, okay, this is the first time. So out of these ones, my first what we are going to discuss in detail is classification learning. Like I said, if it is a weather data, I will explain this weather data problem. Like, depending on weather, let's say we are trying to find out whether to play or not a particular game. We know definitely if it is outdoor game, if the weather is bad, we could not play, like let's say cricket, right? So giving different weather conditions, we should be able to predict whether to play the particular game or not. So this is an example for classification learning. So this is called supervised because we are focusing on predicting one particular attribute, which is we call class. For example, here we are trying to predict whether to play or not. It's a one particular attribute or one particular outcome. And how do you say this is a success? Right? Now, weather tomorrow's weather, we can say by looking at today's weather, we can maybe predict or guess that okay, tomorrow is mostly a sunny day. But the actual value known by tomorrow, right? So the actual value will be available after some time. So you can measure the success. So usually success means you have a separate data set, or we call test data set, right? Okay. So that's about the different types of problem and classification. So today I'm going to show you how we can perform classification. But before that, we need to discuss something. Now, when we need data to analyze, data coming from different places, from different departments. So that means if you know the relational databases, for example, you have data in different tables. On the other hand, when you want to analyze data analysis, if you want to perform, you have to put it to one single file. We have to put into one single file, which we call flat file. So if your database is normalized one, usually we will perform denormalization, which means we are going to have only one table of values to analysis. So remember this, if you have a data in different files, maybe you have to put them into a single file for analysis, right? There are some researchers work on relational data, that means data in different tables and so on, but common algorithms and what we are going to discuss here assumes that your data is in a single file or single flat file, right? Next, I would like to discuss these data sets, and in the data set we have number of records, and each records we can describe by different attributes. Like let's say patient details. If you take patient details, we will have For example, patient name, patient address, patient age, right? Blood type, other tests and so on. So these are known normally as attributes, right? So every instance, that means any record, we can define by this set of features or the attributes. So a patient can be defined with the name and address and so on. That is with a set. But number of attributes may vary depending on the problem, right? So some places the attributes are fixed, some problems. In some other problems, attributes are not fixed. So that's why we have this irrelevant value flag. Meaning, like, for example, if you take pregnancy is not relevant for example, men. Right? Similar thing could happen. One thing to note here is that number could be varied. Now, sometimes these attributes depend on other attribute. Now, for example, if you have an attribute called spouse name, that depend on whether you are married or not. Okay? Like in pregnancy, for example, it depends on the gender, for example. And these are some of the issues that we need to handle. And then in further, you have different types of attributes. You have nominal types. Nominal mean categories like outlook, sunny, rainy, overcast. That's some categorical value. If you take temperature, for example, we can say, okay, high, medium and low. This is nominal, we call. And sometimes you have an ordered, right? When you say ordinal, that means there's an order. So when you say temperature high, medium, low, then there's an order, right? If you take grade of a subject, there's an order. So ordinal type. Then you have intervals, right? There are some range of values which we use in attributes. And then also you could have ratio. So these are the different types. Right. Although you have different types, remember, normally all these algorithms either separate this as a numerical attribute or nominal attribute. So that means, although there are many different types of attributes, mainly almost all our computer programs right now handling attributes as nominal, meaning categories, or numeric. Right. So keep this in mind. Right. Now we discuss the data set. Now we have to think about preparation. When you get data as it is, sometimes it's not in good quality for the analysis. Right. Now, for example, when you get data from different sources, same person can be in different names. Right? So some department you might use first name, last name, some department you might use initials and the surname, there will be a lot of issues. Even date formats, right? You can have date formats. Oh, Chanaka? Oh. Right. Okay. Right. And then different time periods, primary keys. Sometimes we have typographical errors, right? So which means we need to combine the data and you have to clean up. Now, usually if the data coming from different sources, we have to have some place where data is aggregated. Usually we use the term data warehouse. Data put into what we call a data warehouse, where you can look at the data, summarize the data in different levels, like you can get average salary, average sales, per day, per month, per quarter, per year, and so on, right? Okay, so sometimes this internal data is not enough. Sometimes you have to get outside data, things like what is appearing in newspapers, for example. Now, when you are going to predict market share value, for example, whatever the existing data might not enough. External news also, like country's political situation, may affect the market price. So which means what data we gathered is sometimes not enough. You have to get it from outside. But most critical one would be the type and also the level of aggregation, which means whether you are going to get it by day, by month, by quarter, and so on. Right. So remember these things, although we are not going to go into details. Always we need to spend quite a lot of time preparing the data. Usually in machine learning project, we say 80% of the time we have to spend data preparation, right? So the remaining work will be almost 20%. That's we used to say that, right? Now once you have prepared the data, now we are ready to analyze. So to explain the further details, I'm going to get a toy problem. So this is a weather data set. We have set of attributes: outlook, temperature, humidity, windy. And this is a classification problem, which means we are trying to predict this particular attribute, which we call class attribute. And these are the records. So what we try to do using this data set, we are trying to identify what a machine learning model is and how we built, right? Okay. Now first thing is, you see there are some attribute value combination, and what we want to do, we want to build a model, right, to predict. Given this weather data set, the program should be able to tell us whether to play or not that particular game. Right? Now for example, when the outlook is sunny and temperature is hot and humidity high, windy force, that means no wind, it says no play. Right? This is like from historical data. Now for example, if you take a cricket game, we know what is the temperature at that time, and we know geolocation, right, humidity, all this information we recorded. So we can look back whether they have played the game or not. When you have bad weather, we have to stop the game, right? Okay. So likewise, we have the set of data. Now, once you have the data, what you should do? Usually we prefer visualization. So that's why we learned yesterday that the Matplotlib library for simple visualization, of course, we discussed. But before we go any further, usually we look at different visualization tools to make the decisions, such as what algorithm we should choose. Right? But when you're working, you have to be very careful. You have to know the data. Right? Now, for example, usually if you are not a medical doctor, if you are a data analysis, so you need the help of a medical expert, because some information you don't know, right? So remember that. So if you are doing data analysis, first thing is you should know about the data. If you do not know, take a help of domain expert. And the second problem nowadays, you have a overwhelming data, meaning you have a large number of data points are available. So what you should do? So the simple solution is, when you have 100,000 records, take a sample, 10% of what is 100,000. Right. Now let's look at machine learning algorithms. Right. Can you tell us what machine algorithms you have heard? Any machine learning algorithms you have heard so far? Have you heard the word neural network?
Yes.
Now you have heard that. Maybe random forest, support vector machine, decision tree. So these are some of the algorithms available, right? And sometimes they talk about nowadays deep neural networks, XGBoost. There are many methods available for the kind of data analysis that you want to perform. But always remember, you have to start with a very simple algorithm, right? So what we believe in this domain is simplicity works most often, right? So always you start with simple algorithms first, and then you can go for very complex algorithm. Now one advantage you will get using simple algorithms, your solution is simple and you can even interpret it. You can also identify why you came to that particular conclusion. So there are many methods like decision rules, naive Bayes, nearest neighbor. These are actually based on very simple ideas. But on the other hand, whether that particular method you have chosen is whether it work or not depends on the domain. That means in a medical domain, right? For example, let me give you some example. Now let's say face recognition. You know, your phone has a software which identifies you, right? And it will open the lock, right? So when it comes to this face recognition, voice recognition, and so on, deep neural networks are quite popular. If you use textual data, text data, right, naive Bayes is quite popular. Okay, right, that's the first thing. So first, remember, when you have a problem, you start using simple algorithm first, and if you are not comfortable or you are not happy with the outcome, then you can go for very complex algorithms, right? Let's move to decision tree. So decision tree is one machine learning algorithm or classification. So I'm going to discuss how decision trees could be used to make classification, like whether to play a game or not, right? Whether a particular person is having a cancer or not, right? So let me briefly discuss this idea. Now, in algorithmically, to create a decision tree, we are using a technique called divide and conquer. In simple words, divide and conquer means when we have a bigger problem, we'll break down it to a smaller problem and we'll try to solve it. So when it comes to decision tree, it will kind of upside down tree structure where you will have nodes, right? Maybe I can try to draw a simple one, like a tree look like you will have some nodes, and then you have branches, right? And then you will have another set of nodes and so on. You go on like this, right? So this is called a node, right? This is node. These are branches. These are branches, right? So at some point this will end. So you will look at, kind of a tree structure upside down, right? Kind of a tree structure you will get, right? Now the steps. When we talk about the steps, what you need to remember is you start putting attribute at the root node. So if you remember our data set early, so which attribute we should take as a root node? So that's one of the decisions we have to make, right? Okay, and then you make branches for each different values. I will explain that. And you repeat this process for each branch, which means you are going to duplicate the same thing. And the stopping criteria is whenever you have the same classification, then you are going to stop. Right. Now let's look at this. Now we have outlook, we have temperature, we have humidity. Right? We have windy, we have a play. Right? So we have outlook, temperature, humidity, windy, and play. So these are the attributes we will have. So based on these 4 attributes, we are trying to predict whether to play or not. So this is a very simple problem that we are trying to handle. Now I am going to explain how you may build a decision tree for this manually first, right? Now one idea is you can look at how attributes will separate the instances. So what I'm going to do, I'm going to take outlook, and whenever sunny, I will check how many we will have play attribute. That means how many no's and how many yeses. So we will mark it like this for each of different values. Right? So in this particular case, when outlook is sunny, we have 3 no's and 2 yeses. Right? So when outlook is sunny, we have 3 no's and 2 yeses. Right. Now when the outlook is overcast, right, you have a value yes, overcast, yes, value yes, yes, right, and then overcast, value yes, overcast, value yes. So we can see that whenever outlook is overcast, it will be yes. Similarly, if you look at for rainy, you will get like this. So this is, we take attributes and branches, and this is how the class label actually distributed. Now the first question that we have to ask is, which attribute you are going to take more important than the others? Which one do you think is more important than the other one? Is it outlook, is it temperature, is it windy, or is it humidity? If you look at pure separation, which attribute do you think is the best one? What do you mean by pure separation here? Which attributes tries to separate yes and no purely as much as possible?
Is it humid?
Yes. Okay, let's take humidity. If it is high, we have 3 yeses and 4 no's. And when it's normal, we have 6 yeses and 1 no. Do you see any pure branch among these 4 attributes? Can you find any pure branch?
Overcast?
Yes, outlook overcast. Whenever outlook is overcast, you are going to play the game, isn't it? So this decision is a pure one. You see the point? My point is, whenever outlook is overcast, you are going to play the game. So if you look at the attributes, if you look at this pure separation, we can see that outlook is the best attribute. Now this place we can stop because this is yes. So we can say that whenever overcast, we can say outcome is yes. But there are two other branches, which is the classification is not pure, which means we have to put further attributes here. So as a second step, what we do, for sunny, this branch, we are trying to fit all the remaining attributes. What is the remaining? Temperature, humidity and windy. We have fit into this branch. Now based on the same principle that we have discussed, if you look at the pure branches, which attribute do you think is best? Is it temperature, is it humidity, or is it windy?
Humidity.
Yes, in this case you will see humidity. Now if you look at the previous picture, in sunny branch we have 2 yeses and 3 no's. If you put temperature and humidity and windy, when you put humidity, we will get pure separation. Now we know that from here, when outlook is overcast, it's yes, right? So we know this is yes when outlook is overcast. When outlook is sunny and humidity high, we can say it's no. You don't play the game. When outlook is sunny, humidity is normal, you are going to play the game, yes. So you see that we can make decisions. Now we are left with another branch here, right? What is the branch? Right? Rainy branch. When you have rainy, you have left 2 attributes, that is temperature and windy. So we can put either temperature and windy and you can see what happens. So if you do so, you will get this outcome. So what is the outcome? Right? This is what we call the machine learning model. Or this is what we are going to use whenever we will get new combination. Now let me take a new combination. Right? Let me say let me say we have a new situation where we have outlook, temperature, humidity, windy. Outlook, temperature, humidity, windy. Right? Let's say outlook is overcast. In short. And then let's say temperature is hot. Let's say temperature is hot. Right? And then let's say humidity is normal. Humidity is normal. Humidity is normal. Right? And finally, windy is false. Windy is false. Let me put F. So what is the play attribute? Play. Whether you are going to play or not play. What do you think? Let's say this
Play.
is a yes.
Yes.
You are going to play yes. Why? Overcast.
Yes.
Outlook is overcast. So if outlook is overcast, it will be yes. Let's say outlook is not overcast. Let's say outlook is, let's say sunny.
Again, yes.
when outlook is sunny and humidity is normal, then it's just, you got the point, right? Now remember this decision coming from the data, right? This decision structure or this model coming from the data. So machine learning algorithm will take this data, whatever you provide, and it will give this decision tree. So next time when you have a new weather condition, by going through this model, we can say whether to play or not. Give any other combination using this model, we can say whether to play or not. Right? So this is exactly what we are going to do in machine learning. So this is one such model. There are any others like decision trees, decision rules, naive Bayes, neural networks, nearest neighbors. There are many other algorithms are possible. I showed you one thing. So everything works like this. You put the data and algorithm give us the model. And we can use this model to predict. That's all you need to remember. Any questions? Now, are you clear about what we are going to do next? If you have a data and if you want to, let's say, try to classify something, what you can do is you use a data set, you collect the data, you apply to some kind of a model. If it is a decision tree model, you will get a decision tree structure like this. Right. Okay. So let's move on. Right. Now, one thing I want to emphasize here, now the decision, when you are going to make the decision which one is the best one, right? When you say which one is the best one, oh, where am I? Oh, අපි 6:30 to 8:30 නේ ඉදාගත්තේ
6:30 8:30
ඔව් මම ලින්ක් එක එවන්නම් හරි right. So which one is the best attribute to put? Then we have to use, some kind of a measurement or criteria. So what I discussed earlier is what we call impurity criteria, right? Impurity means how purely we can separate the data. So this is what I have indirectly explained. But when it comes to algorithm, or if you are trying to write a program, there's a mathematical basis for this, which we are not going to go into detail. But the idea coming from computing information, right? How much information you will have in a data set and how much information you have after you split the data based on attribute, right? So mathematically we can find like this. So there are many methods we have. Information gain is one such way we can identify which attribute to put in the root node. Similarly, we can use gain ratio, we can use Gini index, right? So some mathematics we can use to identify which one is the best. So in our case, we had outlook is the best attribute to put. So if you calculate mathematically, it will give you the largest possible value for outlook. Okay, so that's just to give you an idea. Right, but when it comes to decision tree, now what we have learned is use of nominal data. Nominal mean categorical data. So you have to handle different types of attributes. Like for example, some you can use numeric attributes. Sometimes you will have missing data, right? So all these we need to think about when you are applying data to a real world problem. Right. Now that you got a model, what do you think? The model accuracy. What do you think for the model accuracy for future data? Will it be 100% correct? For example, take a weather report. Right? How accurate the weather report? Is it 100%? How about financial forecast? What might happen in next week, next month, or next quarter? What is your experience? When you have prediction, yes?
Not 100%.
Yeah. So it might not be 100% correct. But maybe you can say, okay, 90% correct. You provide a name, right? A number for that. You will quantify your accuracy. So similarly, in machine learning also, we have to quantify, meaning like we need to have a measurement to say how predictive our model is. Now for that, we need to evaluate. Evaluate means we need to identify whether the model that we have developed, right, give us the correct outcome for fresh data. Right? When you say evaluation, basically we can do a couple of things. One, we can develop the model for some training data, and then we can test for the remaining data. Why we are doing this? Because we want to make sure that our model is accurate so that we will get decent accuracy for new or fresh data. Right. Now, when you have a large data sets, for example, right, then we can separate as training and testing. And you can use a lot of other measurements, like accuracy is one such, but there are others as well. Total cost and benefit, lift, ROC, which I'm not going to go into detail, but these are some kind of a measurements which will tell us how reliable our model is. And this depends on the data size as well. If you have enough data, let's say you have 100,000 data, then you can say, okay, you have a large data set. If you have a large data set, then you can simply divide the data set as 2/3 for training. That means to build the model. And we can keep 1/3 for testing, meaning we can check model predictions with the test data. Right? So it's same as our weather data set you have seen. You take part of it to build the model. The remaining part we can use it to predict, and you can compare the prediction with the actual label. But if you do not have enough data points, then you have to use other strategy. So usually in machine learning, when you get the data set, we'll divide the data set as two parts. One is called training set, the other one is called test set. Then training set, we apply our algorithm, we'll get the model. For example, our decision tree. Then once you get the decision tree, you use the test set to make the predictions. So you compare the predictions with the actual value, which will give a value for the model. So maybe it might say as, okay, 90% correct, 80% correct. Right. Now, if you have a two-class problem, right, what is the minimum accuracy you expect from a model? If you have a two-class problem, let's say play, not play, what is the accuracy you expect from a model? What is minimum accuracy?
51% or 50?
It should be 50, right? Because we
Yes.
know that random, if you randomly guess, it will be 50. So your model accuracy should be at least 50%. Otherwise, there's no useful use with the model. More the better, but at least it should be better than random chance. So make a note of that, is very important. Right. Why I am saying sometimes you can't say 50, because if you have 3 classes, then the random chance is 33%. If your model accuracy is 50, means it's better, far better than random chance. If you have 4 different classes, your random chance would be 25%. If you say your model accuracy is 50, it's far better than the random chance. So make a note of this. Right. Then you have to optimize parameters of the model, like in a decision tree, how many attributes you want to use, the depth of the decision tree, number of instances in the leaves. So likewise, any algorithm, you have some parameters to tune. For example, k nearest neighbor, where it look for nearest instance labels, right? So the number of nearest neighbors to be used is a parameter. So if you want to parameters, then you have to have a separate data set, which we call validation data. So training and testing is not enough, right? We need a separate data set to tune any parameters, right, in the algorithm. Okay, so if you want to really use all the data points available, one thing you should do is, once you perform the evaluation, you should combine them and find the final model, which I'm going to explain it to you with our data. Right. One last thing I want to show you. So this is how the whole process. Usually we perform training and we use the validation to predict our model parameters, and then you can use both training and testing to come up with the final model, and then you can evaluate using final test set. Right. Okay. Let me explain these things with the small toy problem by introducing it with scikit-learn library. So open Google Colab. Just go to colab.google.com. Open up a new notebook. So let me share the screen. Right. Can you see my screen? Right. So I will take a new notebook. Right. Let me introduce the problem first in another separate one. As I told you, I am going to explain to you about separating data on 3 different types of flowers. This flower is known as iris flower, and there are 3 types. and if you visually look at, they all looks the similar. So without an expert, very hard a general person to separate the flowers. So what we are trying to do is we are trying to apply machine learning. To apply machine learning, you have to collect data, right? You have to have some measurements. So in this data set, right, they measure the petal length and width, sepal length and width. So we have 4 attributes. And then we also mark the type of the flower. So in this data set, we will have 150 samples, 150 records. That means 50 each for 3 different classes. 50 samples each for 3 different classes with 4 features. So using these 4 features, we can create a class label, or we can create a model to predict the class label. So this is exactly what we are trying to do. Okay, so let's start. First of all, we'll get the data set. Let's start with importing libraries we need. So I'm going to import NumPy because we need as NP. Then import matplotlib. This is a library we use for visualization. This is also I'm going to rename as PLT. Right. The new Python module is scikit-learn, and using this dataset, I'm going to using this Python module, I'm going to load some data. So the iris dataset is inside, so we are going to say datasets. Okay, run and make sure that there's no errors. Without any issue, you should be able to load the files. Right, spelling mistake, matplotlib should be T. Yeah, that's fine. Right, now let me take the data set. Now dataset is, I'm going to get the datasets dot, I'm going to use load and whatever the iris. So you can see there are many datasets available. The load wine, load iris, load diabetes, load breast cancer. These are some sample datasets available. So I'm going to select load iris. Right. So I'm going to load the dataset. I'm going to store with the new name iris. Right. And then I'm going to print what is inside iris. Run and observe the outcome. I forgot brackets here. You have to apply brackets. Yes, you should get dataset like this. If you finish up to this point, can you please raise your hands? Right. Yeah, thanks everyone. You can lower the hands. Now if you look carefully, this is a dictionary where you have some labels. Right. So for example, here we have a data, and this is a numerical Python array. Right. NumPy array will be there. Right. So the data is separately the 4 attributes, and the target means our flower representing categories using 0, 1 and 2, and their names are given here: Setosa, versicolor and virginica. These are the 3 types of flowers. Right. So that is the data set. Next, let me show you how we can get data only. Right. So I am going to get the data sets and the target variable. So basically I am going to do assign data and class label or target, right? So I'm going to get the data as capital X. So iris.data will be the data set, data part of it. Y equals iris.data, that is label set. So if you print X, you can see what will happen. Yeah, only the data set is given. And if you say print Y, it will print only the class label. Sorry, this should be target. Sorry, target. So the Y should be the class label, right? You will get in this. So here we have 0, 50, 150 the second class, 250 the third class. So you can just check the size, shape. You can get print x dot shape. Yes, x dot shape means the data set is 150 records with 4 attributes. Here we have 150 records. Right. Now if you just want to see only the first 10, I hope you remember we discussed these ideas. We can say x first 10 records. We can simply type it like this. And similarly, first 10 records of the labels, we can get it like this. So if you print it like this, you will see this is first 10 records of the data set. And then next you will get first 10 records of the class label. If you finish up to this point, please raise your hands. Right. Okay. Those who are having any issues of loading data set? Anyone? Right. Let's visualize the data set. I hope you remember what we have covered earlier. Now when you look at the visualization, we have 4 features. Right? We have 4 features. I will just print. No, I'm going to just say X. I'm going to say first 10 records. Right? First 10 records, we can take it like this. Yes, we have 4. Right? I'm going to select first one and the third one. Only 2 columns. Why 2 columns? I'm going to draw a 2D plot. So I'm going to choose first record and the third. Right? This is how I'm going to do. Right? I'm going to say, comma, this is number of rows. First row, sorry, first column and third column. I put indexes like this. So if you run it, you will see you are getting only 2 columns of data. If you ask me why this, because this is where you can nicely see the 3 categories. So that's what I did. So I will take all the rows and only I am selecting the first column and the third column, right? So I'm going to rename this. I will save this as xplot, right? And you can look at what xplot is. Yeah, you are getting like this. Okay, so let me show you how I'm going to do. Now I have 2 columns. I'm going to make a plot using this. Remember, the command is plt plot, and we have to define what x is. As a x value, I'm going to get the second column. So I'm going to say x plot second column, that is x. Then I'm going to take y, the first column, right? So if I do this, you get something like this. If you are wondering why this happened, because you have a line drawing here, so we can only make a mark. So let me put O, right? Okay, now you can see the dots. Let me put red, for example. Okay, now you can see our data points, 150 points. Visually we can see. Sorry. Right. If you finish up to this point, can you please raise your hands? So what we did so far, we load the data set. We had 4 columns. We select only 2 columns. And we visualize it. One column taken as x, the other column taken as y. That's all we did. Okay, good. You can lower the hands. Now, I want to have separate colors for 3, because I want to visualize and see to know that whether we can really visualize them, really separate the data, right? So now, right now, what I have here is all the data points. Now I'm going to use a simple trick. The trick that I'm going to use is, I'm going to take 1 instances of 1 class at a time. See whether you can understand this code, right? So what I'm going to do, I'm going to make a plot, separate plot, right? The right now, what we can have it, right? We can have it x plot, right? This is what we have earlier, colon and 1. That's the first one. Then we have x plot. We had 0. This is what we had, comma arrow. Right. So this is what we had earlier. But I'm going to limit this. I don't need all these rows. I need only for the first class. So we can take y and we can say if it is equal to 0. If you put this one, it means you take y, all the rows when it's 0. So you get the index for that. and you print it as print in red color. So this time what I did actually got only the first class and put it in red. Similarly, I can change this to indicate the second class if you put 1 here, right? So now I have 2 classes but in the same color, so I'm going to change this red to green. Okay, now we have drawn 2 classes. Similarly, same thing I can copy it again. Now I can change the outcome, the class, as 2, right? This is also 2. Color I'm going to say blue. I'm going to put B. Now you can see it nicely. You can see the 3 classes. There are some overlapping here, right? But that's okay. Now let me put the other details. These things we have discussed. I will put the titles. I will put the labels, right? And finally, I'm going to say plt.show. If you finish up to this point, please raise your hands. I will explain what I did. Now earlier in the previous graph, we print everything together. Now with this, we will take only the first 50 point. Then we'll take second 50 point. Next we will get last 50 points. When class is 0, that's the first class. Then the second class and the third class in 3 different colors. So now we can see that, yes, there are some groupings we can visualize and see. Grouping is possible, isn't it? Any issues? Right. Bamunu, what is going on? Finished? Ajay?
Yeah, just
Okay. I'm waiting you to raise your hands. Please do so, otherwise. Right. So visualization, I told you, like, it's a tool that can be used to see what is inside the patterns. Now, of course, this is actually purposefully we select only 2 out of 4. Right. You can lower the hands. Thanks. Right. We can move on. The next part that I'm going to discuss is separating data. Now, I told you we have to separate data as train and test, right? We have to separate data as training and testing. Why we are doing this? We will take part of the data to build the model and we need to evaluate this, right? Now, for this we have to use scikit-learn, sklearn dot model selection. We can say import train test split, right? Now let me show you like how we can do this, right? So what I'm going to do is train test split. What we are going to split? Both x, that is the data, y, that is the class label, and then we have to define what is the size of the test data set. So I'm going to say that it's 33%, meaning 1/3 basically. This is to a 1/3. Now when you apply this, what happens? This will return 4 things. First of all, x train, then x test, then y train, then y test. So you divide the data set and we are going to store training under x train, testing under x test. So this is data points. This is labels for training and testing. So if you do that and if you check the sizes, so for example I can say x underscore train dot shape, print x underscore test dot shape. Shape give you number of rows and columns. So if you do that, you say training set consists of 100 instances, test set we will have 50 instances. So anyway, I mean, if you have issues with typing the code, if you have like any mistakes, you can download the code. I have already put this file in the Google Classroom. So make sure that you will go there. Right. Now, finished up to this point? Please indicate whether if you are finished. Right. So I might not be able to discuss everything, so better you can go to Google Classroom, right? Inside the Google Classroom I have already put the file for you. You can download it here. So classwork, right? And then we have machine learning in Python, Okay, so there's a Python file you can download here, right? This one contains all the codes, right? Now let me show you a couple of things what we could do. Now we need to build the model. Remember, we discussing which attribute is the most important, put it, and we discuss some process, isn't it? So that is build in the model. So let me explain build in the model. Build in the model. For this case, I'm going to building a decision tree, right? And for that, we have to get sklearn import tree, and then we have to identify the classifier as tree dot decision tree classifier, right? So this is basically you are selecting a decision tree. No issues. Now let's train the model, right? Let's train the model. So training model, we can say classifier dot fit. When you are training, we use training and label also y-train. So we are using only training sets to train the model. So this will give you our tree model. So we divide the data set as training, testing. We build the decision tree model. We select the decision tree model, then we train the model. Now the model is ready. Later on I will provide you the code for visualizing it. Right now we have the model, although we can't see. Now let's see the prediction for test data, right? Predictions. Now when we want to predict, let's say predictions, we can say classifier predict x test, right? We can say predictions So what it means? Now remember, our test set consists of 50 data points. So this is predictions. Let me put print statement predictions. So we use in the model to predict it. Now my question, where's the actual values? Can you tell me, where can I find the actual values? This is prediction used in the model. We got the test data set, we apply it. These are the y values already predicted from the model. Where's the actual values? Yes? Where can I find the actual values of the test set?
It was there in the original date.
Yeah, y test. I'm waiting for you to get this one, because when we divide the data set, we got this actual value. So the prediction, we use model, use in the data set only. We got the predictions. Right. Here is the actual and predictions. By looking at this, can you tell me what is the accuracy? If you just by looking it, can you guess what might be the accuracy?
White cross, huh?
Yeah, so there's a
Let's see, 100%.
yeah, let's see is it 100%.
Sorry?
Let's see whether it's 100%.
It's not right.
Not right. If you look at the first
Yeah.
one, it's 0 0. Second one, it predicts 2, but actually is 1. So there are some misclassifications if you find, right? To look at this, let me write the code to get the accuracy from sklearn. It's called matrix import accuracy score. We can say print accuracy score. We can compare y-test with predictions. So when you compare, right, yeah, bracket missed, you can see it's about 94%.
So what you are doing here is the evaluation, right?
This is evaluation. So if you want to find predictions for new data set, you can provide some values here. So it will give us the prediction. We have 4 values. If you measure a new flower, and if you give these values here, you will get the outcome, predicted outcome. Right. Okay. So with the time, I do not think I can, cover everything, but let me show you the code for displaying the model. You can try this. This is the code for that, and outcome will be something like this. This is the decision tree for this data set, and what you see in the top in the root node is a petal width. If the petal width is less than or equal 0.75, right, this says, if it is true, this says the class is setosa. If it is false, then you can check again petal width whether it is less than or equal to 1.75, right? And then if it is greater than that, you can get the class as Virginica. So you can visually observe the model, right? But remember that in not all the algorithms you can see like this. It's not possible. It's not possible. But decision tree is a nice algorithm where you can see exactly how classification happens. Okay, so this is my basic introduction to machine learning. So what I tried to cover is give you the basics of machine learning, and then give you some practical or codes where you could actually implement this. Actually, I have briefly shown you some of the important steps and how can we do this in Python. Right. So with that said, I'm going to conclude that part. Any questions if you have before we move further.
How can we export this classifier? Maybe to use at some other.
Yeah, you can actually export mean you can save it. In Python, there are many ways where you can actually save it, right?
So I meant the model that we trained. I mean, how we are going to reuse it? So
Yeah, you can keep it as a file,
Okay.
right? Let me show you. So the command is, let me direct you where you can find the answer. So saving, you can use, there are many ways you can do this. Let me show you some codes where you can use. I will share this article with you, right? When you want to save a machine learning model, one way to use is called pickle string, where you can keep it as a file and then later you can use it, right? So what you see here is we are training a model, the same codes we have discussed, and then, right, we can save as a pickle. We will save the model using pickle module. We can save it and later on we can get back, right? So that is one of the simplest ways that you can actually do this. So you can specify it as a file name as well. For example, let's say in the next example they showed you, you can save the classifier as a separate file, and next time when you need it you can load it from the file. So I will share this with you so that you can go through, read about this, and it's not that difficult as well, right?
Okay. Thank you.
Yeah, I think you got the idea, right? Okay. So you need a little bit of practice. I think you can actually read a lot. There are plenty of material out there you could try. So since we have learned the basics, now you are ready to explore. Right. As a second step, I want everyone to go to Google Classroom again. And there was a survey question here. Can you click and complete? Let's use about 5 minutes or so to do this. Because this survey is important for us for next offering, so that we can provide you a better training, at least for those who get the same course again. Please complete the survey. Once you complete, please raise your hands so that I can move to the assessment part.